Hey, our aim for this lab was to construct a motor from the supplied material. As a secondary aim, we were to estimate the speed at which the screw rotated. A single AA battery, an insulated wire, a screw, and a magnet were given to each group. At this point, our group did not understand the physics concepts that would allow us to make a motor from these four things. Because of this, the method we used was trial, error, and observation. As there were only so many configurations these four items could be stuck together, it did not take us long to correctly construct a functioning motor. It was on our second attempt that we correctly assembled the motor. This was done by connecting the magnet to the head of the screw, connecting the now magnetized tip of the screw to the bottom of the battery, then touching the wire to the top of the battery and the side of the magnet. At this point, the screw began to rotate. We observed that the motor would only work when the wire was connected to the side of the magnet, not the bottom or the top. Additionally, when the magnet or the battery was flipped, the direction the screw spun was reversed. Following this, we then attempted to calculate the speed at which the screw was spinning. In this instance, rather than simple trial and error, we took a more structured approach. We placed a dot of whiteout on the side of the magnet to make a single revolution more obvious, then filmed the motor in action using the slow-mo mode of our cameras. As the slow-mo camera filmed at 240 frames per second, but the slow-mo video, when played at 30 frames per second. Each second of the played slow-mo video represented 1/8 of a second in real time. We counted 40 revolutions across a 10-second period, which equaled 4 revolutions per second in slow-mo time, which equates to 32 revolutions per second in real time. There were some uncertainties in this calculation, as the speed of the rotating screw varied from video to video that we took. In some videos, the speed was so fast that even in slow-mo, the revolutions could not be counted. The value we used in our calculations was from the 10-second period, with the highest revolution count we were able to observe before it began to move too fast to see. Because of this, 32 revolutions per second should only be taken as the minimum value. The motor that we created was a homopolar motor. The battery and wire created an electrical current, and the magnet had a magnetic field. When the two cross each other at a perpendicular angle, a force occurs and causes the screw to spin. When a current and a magnetic field interact at a perpendicular angle, a force is created that is perpendicular to both. This force is known as a Lorentz force. When the current and magnetic field is parallel, there is no force. This explains why when the wire was connected to the bottom or top of the magnet, the screw didn't spin. Additionally, inverting either the magnet or battery would have inverted the directional flow of either the magnetic field or current, respectively, thus inverting the direction of the Lorentz force. This explains why the direction the screw span changed when this was done. After some trial and error, our group was able to create a motor and estimate the speed at which it revolved. After conducting some research, I now know that the motor we created was a homopolar motor, which was powered by Lorentz force. When the circuit was completed by connecting the wire to the side of the magnet, an electrical current was created that was perpendicular to the magnetic field of the magnet. This caused the screw to spin due to the Lorentz force that was perpendicular to both the electrical current and the magnetic field.